peak data rate. So we have the goal of 20 gigabits per second. 20 gigabits per second. So that is 20,000 megabits per second. So here, when we have all the resources of that cell, that sector given to us, and we have excellent channel conditions, then we will be able to experience 20 gigabits per second. In IMT Advanced, our 4G, we have the goal of 1 gigabits per second. So we are now significantly increasing our target from 1 to 20 gigabits per second. How about user experience data? The average data rate we can experience anywhere, whether we have good channel conditions, poor channel conditions, it does not matter. We should be able to enjoy how much? At least 100 megabits per second. So 10 times this 10, 100 megabits per second. So we are going from 10 megabits per second in 4G IMT Advanced to 100 megabits per second. Pretty good jump. So this will help us enjoy our videos even near the cell edge. Spectral efficiency. How efficiently we are using the precious radio spectrum. Remember, we have given our governments billions of dollars. So we need to squeeze everything out of the spectrum. Just like we would like to get every drop of lemon juice using lemon squeezer, we want to get all those bits out of the spectrum. So we want to become 3 times more efficient in 5G. So bits per second per hertz compared to LTE 4G technologies. Now we want to become 3 times more efficient in 5G. User mobility. So we talked about the bullet trains. So our goal is from 350 kilometers per hour. We are now going to support good services, good quality service even at 500 kilometers per hour. Latency. So our goal for the radio network latency is 1 millisecond instead of 10 millisecond. Okay, so this is the radio network related latency. So let's say we have a base station, an IP packet comes at time t1, and now we want to send that packet to the device, and the IP layer at the device is getting that packet at time t2. So that difference in time, our goal is less than a millisecond. Pretty fast. So we are improving the latency performance by factor of 10. Instead of 10 millisecond radio network latency, we have 1 millisecond target for 5. Connection density. So think about smart city type application. So we want to support lots of those low data rate IoT devices. So in 1 square kilometer area, here we have 100,000 devices in 4G. Instead of 100,000, we want to support 1,000,000 devices. 1,000,000 low data rate IoT devices that are delay tolerant. They can tolerate delays. So 1,000,000 devices per square kilometer. Energy efficiency. Right? So we need to make sure we are environment friendly and try to minimize the utility costs. So instead of, let's say, 0.1 as our scale here, 0.1 times 10. So instead of 1, we are making it 10 times 10, 100. So from 1 to 100, we are becoming more energy efficient in 5G. Okay, so for example, if you do not need some high capacity cells, right, we can turn off those capacity cells and have the basic coverage for that area. So that kind of features we can implement to improve the network energy efficiency. So basically we want to become better by a factor of 100 in terms of how we use the energy. Area traffic capacity. So this is for hotspots. So you can now aim for 10 megabits per second in 1 square meter area. So imagine a tiny 1 meter by 1 meter area. So in that small 1 square meter area, we want to get 10 megabits per second. So that would be good for hotspots like airports, shopping centers, and so on.